find the zeros of this polynomial, then graph. The zeros have nothing to do with this leading coefficient, but one of the zeros is going to be at x equals 1. One of the zeros is going to be at x equals -2. But notice that's an even exponent, so that's going to touch and turn at x equals -2. At x equals -5, there's a go through because that's odd. It does not touch and turn. It actually just goes through. So let's get the xy axis going here. I'm going to plot my zeros. My zeros are at 1. My zeros are at -2. That one's going to touch and turn. So I'm going to make a note to denote that. And the other one's at -5. -1, 2, 3, 4, 5. It's going to go through those 2 points and touch and turn at that point. Let's see what the end behavior of this is. This is x to the first. This is x to the second. And this is x to the third. So when I add those all up, I get x to the sixth. And x to the sixth is like x squared. It's going to end up on the left and up on the right and have stuff going on in the middle. But I'm not doing the middle in this problem. I'm actually going to get a lot of bumps and stuff going. So let's see what happens. I know positive x to the sixth would go up, up. But negative x to the sixth would be down, down. It would end downward and then cut through a couple of times. So at this point, I'm going to put an arrow pointing downward. At this point, I'm going to put an arrow pointing downward. And then what I'm going to do is I'm going to try to get the graph. Notice I go through there. Now it's got to turn around and go towards this spot. But at that spot, as soon as I hit it, it touches and turns. And then it's going to go through up here and then go back down. And we can plug in values to get values at, let's say, -1, -2, -3, -4, and 1, and see what it says. A good way to get those table of values is to use the Casio. And I'm going to type in mode 7, and I'm just going to type it in like it looks, -2, parentheses, x minus 1, x plus 2. Whoops, that's an x plus 2 squared, cubed, and there it is. I'm going to hit equals, equals. I'm going to start at -6, end at 2. Step by 1, and it gives me all the values. So at -6, it's really far negative. At -5, it's 0. At -4, it's 40. So using those values, I can place them on my graph. So I can put that 40 up here at -4. It said at -3, it was 64. I know this is not the scale. And at -2, it was 0. And then at -1, it was way up here. It says 256. That's not the scale. At 0, it says it's at 1,000. Again, not the scale. And then over here at -2, it says that value is -10,976. Once again, not the scale. I don't think we really need it. Another piecewise function. What they want me to do is plug in for a, -1. So f of -1, and notice -1 is less than 0, so I'm going to use the top equation. So it's going to be 2 times -1 plus 1, so -2, that's going to equal -1. For b, I have to plug in 0. Which one do I plug 0 into, the top one or the bottom one? Notice 0 is greater than or equal to 0, so I'm going to plug it into the bottom one. So when I plug 0 into there, that's going to give me 2 times 0 plus 2, or just 2. For part C, I have to plug in 2. Notice 2 is greater than or equal to 0, so I'm going to be using this function. So for part C, it's going to be 2 times 2 plus 2, that's 4 plus 2, that equals 6. So far, this one's -1, this one's 2, this one is 6. Now for part D, they want me to plug in t squared plus 1. So that's going to give me 2 times something plus 2, but I have to type in t squared plus 1. Well, heck, I don't know if that's greater than or equal to 0. I kind of do, because no matter what I plug in to t squared, it's going to be positive. And a positive number plus 1 is always going to be greater than or equal to 0. So I think that means I only have to evaluate it for this problem. When I evaluate that, I have to distribute to 2. That's going to be 2t squared plus 2 plus 2. And that equals 2t squared plus 4 is your final answer. 24, evaluated at 4. So I take that 4, so part A is going to be 5 minus 7 times 4. 5 minus 28 equals -23. This time it's going to be an expression for part B. I take part B and I type it in. 5 minus 7 times x plus 3. Now I have to simplify it or evaluate it, so that's going to be 5 minus 7x minus 35. So 5 minus 35, that's going to give me -7x minus 30 for part B. Part C, it's basically a even odd question. You plug in -x, so that's going to give me 5 minus 7 times -x. Negative times negative is positive. That's just going to give me 5 plus 7x. Some people might write it as 7x plus 5. 25, use the quadratic formula. So I have to bring this over. This is going to be x squared minus 2x minus 4 is equal to 0. A equals 1. B equals -2. C equals -4. B, negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. And I'm going to have to use that again, so I'm just going to paste that over and use it again for the next problem. Let's see what happens when I plug this in. So b is -2, -2, -2. A is 1, 1 there, and then -4 goes in the back. So it's going to give me -2 is positive 2 plus or minus the square root of 4 plus 16 all over 2. That's going to be 20. So square root of 20 breaks into 4 times 5. So that's going to give me 2 plus or minus 2 root 5 over 2. And let's notice that the 2 simplify. So that's going to give me 1 plus minus root 5. And that's my final answer. For this one, it's already in the correct format, so I'm going to start off with B. So it's going to be negative 2, negative 2. A is going to be 1 again. And C is going to be positivo 19. Negative 2 is positive 2 plus or minus the square root of 4. And then negative 4 times 19, or times 19, 76. So that's going to be 4 minus 76 all over 2. 4 minus 76 is negative 72. So this is going to give me 2 plus or minus the square root of negative 72 over 2. I have to simplify that negative root 72. I don't know if you knew this, but root 72 was 36 times 2, so it's going to be 36 times negative 2. Square root of 36 is 6. Square root of negative 2 is I root 2. So this is going to give me 2 plus or minus 6I root 2 all over 2. And we'll notice how stuff starts to simplify. Those 2 simplify, the 2 and the 6 simplifies. So this is going to give me a final answer of 1 plus or minus 3I root 2. Solve each equation by method of my choice. So the first thing I'm going to do is divide by 2. I could have squared both sides. I don't know. So that's going to give me the square root of x minus 1. And that's equal to x over 2. I'm going to square both sides. And that's going to give me x minus 1 equals x squared over 4. Now I'm going to multiply both sides by 4 to get rid of the fraction. When I do that, I have to distribute it. So that's going to give me 4x minus 4 equals x squared. Subtract x squared from both sides. That's going to give me x squared plus 4x minus 4 is equal to 0. I'm going to factor this. And that's going to give me x times x equals x squared. 2 times 2 equals 4. Actually, negative 2 times negative 2 equals negative 4. And negative 2 minus 2. Let me see what happened here. Distribute that 4 across. So that's going to give me 4 minus 4x. 4x minus 4 equals x squared. That's going to give me x squared minus 4x plus 4 is equal to 0. Let's go ahead and factor this. That's going to give me x minus 2 times x minus 2 is equal to 0. X equals 2. When I plug it back in, 2 minus 1 is 1. 2 times the square root of 1 is 2. And x equals 2 is over there. It works for the final answer and for the original equation. I'm going to solve this absolute value. I'm going to add 3 to both sides. That's going to give me absolute value of 2x minus 5 equals 3. This is going to set up 2 problems. So that's going to give me 2x minus 5 equals 3, or 2x minus 5 equals negative 3. And now I'm going to solve this rapidly by adding 5 to every side. So that's going to give me 2 equals 2x plus 8. Divide everything by 2. It's going to give me 1 equals x, or x equals 4. So my answer is formally x equals 1 or x equals 4. The cubic, let's see what happens with that one. Number 29. Let's get everything on one side. So that's going to be x cubed plus 2x squared minus 9x minus 18 equals 0. I basically just subtracted 9x from both sides and subtracted 18 from both sides. Now I'm going to factor this by grouping. I'm going to group the front items, and I'm going to group the back items. I can factor out an x squared from the front items. And when I do that, it gives me x plus 2. Since this is factored by grouping, this has to be x plus 2 also, otherwise it wouldn't be a math problem. Now if I come in and hide that back end, everything up front, and just look at the back end, what's negative 18 divided by 2, and that's going to give me a negative 9. And that's the number that goes out front. Notice I could have pulled a negative 9 out of that. Now I'm going to factor it one more time. So that gives me x squared minus 9 times x plus 2. I can factor it one more time. That's going to give me x plus 3 times x minus 3 times x plus 2. If it wanted me to solve it, the answers would be x equals negative 3, x equals 3, and x equals negative 2. Find the domain of x squared. If you were to graph it, it would just look like a big parabola. So that domain is going to be all reals, and all reals in interval notation. Let's get back to that. All reals in interval notation is going to be from negative infinity to positive infinity, but they're in parentheses. This one, I'm not allowed to take the square root of any negative number, so it has to be greater than or equal to 0 what's underneath the radical. So 8 minus 2x has to be greater than or equal to 0, and when I solve that, I kick the 2x over, and that gives me 8 is greater than or equal to 2x. I divide both sides by 2, and that's going to give me x is less than or equal to 4. So if I were to graph that on the number line, I would have a number 4 there, and it would be circled with a colored in dot, and the arrows would be pointing to the left. And now when I want to answer that for the College Board, that's going to be from negative infinity up to 4 bracket, and that's all there is to it. For this one, it's kind of touchy. I might take this one over to another page. There's a lot going on with number 32. Now we just showed that what's underneath the radical has to be greater than 0, can't be negative, but the bottom, in this case, can't equal 5. So I got to make sure I write down that x cannot equal 5. But for this one, I have to take the guts, x minus 2, and set them greater than or equal to 0. So I add 2 and I get x is greater than or equal to 2. Let's go to the number line. So I have the number 2, which is included, and then I have the number 5, which is excluded. So it has to be every number but 2 and 5. And in order to write this in interval notation, you have to break it up. So in interval notation, it's going to be a bracket, 1 to 2. Comma, and notice it goes up to 5. I shouldn't have put a bracket on that. At that hole, it can't equal 5. It should be a parenthesis. Then I have the hole, and now it's not allowed to equal 5 on the right side. So it's going to be union, parenthesis 5. And then it goes all the way over here to the right forever, and that's going to be the positive infinity. Now, a little thing we need to know is that you never put a bracket on infinity or negative infinity. You always put a parenthesis. Now I want the domain of ln of x plus 2. Well, if I were to graph ln of x, it's like a logarithm function, and it goes through 1 and creeps up along, has a vertical asymptote of 0, and then slowly grows gradually up and to the right. Now, I'm going to shift this left, the opposite of that, too. So from there, I go left, 1, which is 0, 2, which is negative 1. Now, the asymptote is at x equals 0 here, so that's going to be at x equals negative 2. That gets moved to the left also. So the actual graph is going to come up alongside negative 2, go through that go-through point, and off to infinity. So that's going to be from parenthesis negative 2 to positive infinity. 34, I'm asked to find the domain and graph it. First, the domain cannot equal. X cannot equal plus or minus 4. Because when you factor that, you get asymptotes at 4 and negative 4. I'm going to graph it. And what I like to do first when I graph it is take a look at the factored bottom, x plus 4 times x minus 4. And when you set that equal to 0, that gives you the asymptotes at negative 4 and 4. So negative 1, 2, 3, 4, there's a vertical asymptote. At positive 1, 2, 3, 4, there's a vertical asymptote. Horizontal asymptote, notice the degree of the top is 1, the degree of the bottom is 2. So there's going to be a horizontal asymptote at y equals 0, which is basically the x-axis. This is kind of strange. I'm going to find the intercepts. So to find the intercepts, I do this little yin-yang thing, and I take the 0 and I plug it in for x. A bracket on infinity, only a parenthesis. And that's the domain. Number 35, same thing. What I'd like to do first is